Hey guys, continuing on with Chapter 8 here, Lesson 8.6, Solving Rational Equations and Inequalities. So a rational equation, we've worked with rational expressions so far. Rational equation is any equation that contains one or more rational expressions. And then a rational inequality, pretty self-explanatory. Any inequality that contains one or more rational expressions. And again, we're going to be learning how to solve both the equations and the inequalities in this lesson. So let's get into some examples here. First thing we want to do, solve each rational equation and check your answer. So the first thing we want to do here, anytime we're working with fractions, I know when I am teaching with fractions, those are usually the problems that people have the most difficulty with, and people just kind of see fractions and immediately don't really want to work with them. So when we're working with these rational expressions, the first thing that I'm actually going to do to solve these equations is I'm going to get rid of the denominators in order to get it to an equation that does not have fractions anymore. Now, my steps in order to get rid of my denominator, the first thing I need to do is figure out what my common denominator is going to be. So that's what we've been doing in the last few lessons, of finding those least common multiples between different rational expressions, or between monomials and binomials. So here, the least common multiple, which would be that common denominator between these three terms, if we look at just the numbers, we've got 4 and 28. The smallest number that 28 and 4 both go into is 28. And then we've got an expression of z plus 2. So our common denominator, or our least common multiple between those three terms, would be 28 times z plus 2. Now in the past, we've just multiplied, like to get our common denominator, we would multiply 28 by z plus 2, and that would give us that denominator. But since I'm trying to get rid of our denominator, what I'm actually going to do here is I'm going to go individually and multiply each term by that common denominator. So if I multiply 9 over 28 by 28 times z plus 2, then I multiply 3 over z plus 2 times 28 times z plus 2. And I multiply 3/4 by 28 times z plus 2. Now, this one, I'm going to take a little bit longer and really go step by step here to make sure you guys are understanding what I'm doing. So if I take 9 over 28, and I multiply that, what I'm doing is, again, I'm multiplying it by 28 times z plus 2 over 1. So now, what I can do is I can cancel my 28s, and I end up with 9 times z plus 2 over 1. So here, my 28s cancel. So then I've got 3 over z plus 2 times 28 times z plus 2 over 1. Here my z plus 2's cancel, and I'm left with 3 times 28, not 23. I'm left with 3 times 28. And then my last one, 3 over 4 times 28 times z plus 2 over 1. My 4 cancels, my 28 will become a 7, so then I'm left with 3 times 7 times z plus 2. So on the rest of the examples we go through, I'm not going to show each step there. I just wanted to show how I'm doing what I'm going to do over here. So again, on my first term, those 28s cancel. My second term, z plus 2 cancels. My third term, the 4 cancels, and the 28 becomes a 7. So then I'm left with 9 times z plus 2 plus 3 times 28 equals 3 times 7 times z plus 2. Now I'm going to go ahead and solve for z here. So when I distribute my 9, I get 9z plus 18 plus 3 times 28 is 84 equals, in this case it'll be 21 times z plus 2, which gives me 21z plus 42. Now I'm going to combine my like terms here. So 9z equals 18 plus 84, which is 102. So 9z plus 102 equals 21z plus 42. Now I want to get the z's to one side and my constants to the other, so I'm going to subtract 21z from both sides. I'm also going to subtract 102 from both sides. So those cancel and those cancel. I'm left with 9 minus 21, which is negative 12z, equals 42 minus 102, which is negative 60. Divide both sides by negative 12, and it gives me my solution of z equals 5. Now, in order to make sure we got the right solution, we want to check our answer. Again, I'm not going to do this on all of them, but this one, just as a reminder of what we would need to do, I would go 9 over 28 plus 3 over 5 plus 2 equals 3 over 4, which would then give me 9 over 28 plus 3 over 7 equals 3/4. Common denominators in order to add over here would be 28, so I'm going to multiply the numerator and denominator by 4. So that'll give me 9 plus 12, so that would be 21 over 28 equals 3/4. 21 over 28 simplifies to 3/4 equals 3/4. That works. So z equals 5 would be the correct solution here. So again, we took that step, we found the common denominator, multiplied each term by the common denominator in order to eliminate our denominators, and from there we were able to solve for our variable. So let's go ahead and do another one here. 7 over 12 plus 9 over x minus 4 equals 55 over 48. So I want to figure out what is my common denominator here. Well, the smallest number that 12 and 48 both go into is 48, and then we've got our x minus 4. Now, when you find your common denominator and multiply each term by that, if you don't get rid of your denominator, that means that whatever you found as your common denominator was incorrect. So again, I'm going to multiply each term here by 48 times x minus 4. Then if I go through, I can eliminate my 12. My 48 becomes a 4. I can eliminate x minus 4, and then I can eliminate my 48 here. So I'm left with 7 times 4, which is 28 times x minus 4, plus 48 times 9 equals 55. I eliminated my 48, so I'm left with just times x minus 4. So this will give me 28x minus, 28 times 4 is 112, plus 48 times 9 is 432, equals 55x minus 220. Now again, same steps as up above. I want to combine my like terms, so I'll have 28x. I've got negative 12 plus 432 gives me a positive 320 equals 55x minus 220. So now again, I want to get my variables to one side, constants to the other. Doesn't matter which side you go with, you'll end up with that same answer either way. So my 55x cancels, my 320 cancels. 28 minus 55x will give me negative 27x equals negative 220 minus 320 is negative 540. Divide by negative 27 on both sides. My solution is x equals 20. Now, if you end up with a problem that looks like this, where there's no addition or subtraction on either side of the equals sign, besides in our denominator here, this is a proportion. So for this one, I don't have to do anything with common denominators. I can go ahead and just cross multiply. And that would give me 3y equals 2 times y plus 1, which gives me 2y plus 2. Subtract 2y from both sides, and I get my solution of y equals 2. So that's just another situation you might run into there. Now the next thing, elimination of possible solutions. So here, what we're going to do, we're going to solve this ultimately the same way. But what I'm going to do first, before I start solving this, is I'm going to rewrite it, and I want my denominators written in their simplest form. We don't have to factor out the numerators here, just the denominators. So I'm going to go ahead and change this to r plus r squared minus 5 over r squared minus 1 will be r minus 1 times r plus 1 equals r squared plus r plus 2 over r plus 1. So now that I've got my denominators in their simplest form, I want to find my common denominator, which here my denominator for r, really I can write this as r over 1. So for my denominator, my least common multiple between these three terms is going to be r minus 1 times r plus 1. So we need to multiply each of the terms by r minus 1 times r plus 1. Then again, I want to go through here. Nothing can cancel from my denominator and the least common multiple. Here I can cancel the entire thing, and in my third term the r plus 1 cancels. So now I'm going to go ahead and I'm going to have r times r minus 1 times r plus 1 plus r squared minus 5 equals r minus 1 times r squared plus r plus 2. Now I need to get this solved for r. So the first thing I'm going to do is I'm going to go ahead and FOIL here. So I've got r times r squared. We know since this is r plus 1 times r minus 1, really, we know that it's going to come down to r squared minus 1 because we took r squared minus 1 and factored it there. So r times r squared minus 1 plus r squared minus 5 equals, I'm going to go ahead and distribute here. So r times r squared gives me r cubed, r times r, so plus r squared plus 2r minus r squared minus r minus 2. So now my next step, I'm going to go ahead and distribute here, and I'm going to simplify this side. So this is going to give me r cubed minus r plus r squared minus 5 equals, when I simplify over here, I've got r cubed, let's see, r squared minus r squared, those cancel. 2r minus r will leave me with positive r, and then minus 2. So now, I'm going to go ahead and subtract, because I want to get this set equal to 0. So I'm going to subtract r cubed, r, and add 2. So plus 2 minus r cubed. So that all cancels. My r cubeds cancel. I have negative 2r plus r squared minus 3 equals 0. Now I want to get this into descending order. So r squared minus 2r minus 3 equals 0. So I know this is a lot of steps so far. We've got one left. We need to go ahead and factor this. So we know we need two numbers that multiply to negative 3 and add to negative 2. In this case, that's going to be negative 3 and positive 1. So then if we set those both equal to 0, we're going to get r equals 3 and r equals negative 1. So again, we came up with our solutions based on taking the same steps that we did on that last slide. These are just a little bit more complicated because of having r to a power higher than 1. But now, again, elimination of possible solutions. We need to look at our two solutions of 3 and negative 1 and see, are there either of those that, looking at the original problem, will not work? The way that we can tell if a solution will not work here is by looking at the denominators. If there's a solution we come up with that would cause a denominator to be equal to 0, then we know that that can't be an answer because it would come up with a solution that is not a real number. And so if we look at this, 3, if we plugged 3 in either of our denominators, that would still work. It wouldn't equal 0. But if we plugged in negative 1 plus 1 is 0. So we know that negative 1 is not a solution here. So our solution would be r equals 3. Now let's walk through one more of these. This one we'll be able to walk through a little bit quicker here. So again, first thing we always want to do is get it written out so that all of our denominators are simplified. So 2 over r plus 1 minus 1 over r minus 1 equals negative 2 over r minus 1 times r plus 1. So our common denominator, looking at our three terms there, the least common multiple would be r minus 1 times r plus 1. So we're going to multiply each term by that. So over here, the r plus 1's cancel. Second term, r minus 1's cancel. And in the third term, it all cancels. So we are left with 2 times r minus 1, which would give us 2r minus 2, minus, let's see, in this case, 1 times r plus 1, so minus r plus 1, and it's all going to be equal to negative 2. So now if I combine my like terms, 2r minus r gives me r negative 2 plus 1 gives me negative 1 equals negative 2. Add 1 to both sides. I get r equals negative 1. But if I look at this, if I plug negative 1 into any of these, does it make my denominator 0, which would make the problem undefined? If I plug it in there, that would make the denominator 0. So r equals negative 1 would not answer, meaning that there is no solution on this problem. So always make sure you check just to be sure that whatever solution you come up with would not cause your solution to be undefined. All right, couple more slides here. Don't know how to say this, Lutschberg Tunnel was built to connect Bern, Switzerland with the ski resorts in the southern Swiss Alps. The Swiss used one company that started at the north end and another company that started at the south end. So we have, we're building a tunnel. So let's say we've got this hill here, and we're building a tunnel to connect the two sides of it. So one side from, let's see, the Swiss used one company that started at the north end, another company that started at the south end. One company can drill the entire tunnel in 22.2 years. The other company can do it in 21.8 years. How long would it have taken the two companies to drill the tunnel? So what we need to do here is we need to figure out how long will it take for these two drills to meet in the middle. So in order to do that, I need to set up an equation that is going to have rational expressions here. If we think of this, in 1 year, this company that takes 22.2 years can do 1 over 22.2, that fraction of the tunnel. In 2 years, it would go up to 2 over 22.2. 5 years, 5 over 22.2. So we can say that t over 22.2 will give us the amount of years that this company will take, plus t, or the time in years, over 21.8, and it's going to be equal to the one tunnel that they are drilling out. So now, just like we did on these last problems, we want to figure out how can we get rid of our denominators. What would our common denominator be here? Our common denominator would be 22.2 times 21.8, which would be 483.96. But for these two, to make it easier to be able to cancel, I'm going to go ahead and leave it in this form. So I'm going to multiply by 22.2 times 21.8. Here, multiply by 22.2 times 21.8. Over here, I'll go ahead and multiply by that 483.96. So here my 22.2's cancel. Here my 21.8 cancels. So I'm left with 21.8t plus 22.2t equals 483.96. When I combine my terms here, I get 44t equals 483.96. Divide by 44, and I get a solution of t is about 11 years. So it would take 11 years for those two drills to meet in the middle and for the tunnel to be completed. All right, so the last thing we're doing here now is solving rational inequalities. So this is going to be similar to solving the rational equations, just with a few extra steps added in. So the first thing we need to do is find the excluded values. In order to find the excluded values, we need to set each of the denominators that includes a variable equal to 0. So here we would say 4a equals 0 and 8a equals 0. These will both come out to a equals 0, meaning that that is our excluded value. A cannot equal 0 because that would leave us with an undefined inequality. Next, solve the related equation. What that means is we're going to take this inequality and rewrite it with an equals sign. So 1 over 4a plus 5 over 8a is equal to 1 over 2. Now we want to solve this. We've already done this on the last few slides. We need to find that common denominator, which would be between 4, 8, and 2. The smallest number those all go into is 8. And then we need to include that variable of a. So our common denominator, that common term we're going to multiply each of these by is 8a. So this will cancel. We're left with 2 here. 8a's cancel, the 2 cancels, and we're left with 4a. So this will give us 2 plus 5 equals 4a, or 7 equals 4a, which would give us, divide by 4, so a equals 7 over 4, which is 1 3/4. So now, step 1, we found the excluded value. Step 2, we solved the related equation. So we came up with, now what we need to do in step 3, use the values determined in steps 1 and 2, so 0 and 1 3/4, to divide a number line into intervals. So here I'm going to take a number line, and I'm going to put 0 on that number line, and I'm going to put 1 3/4 on that number line, and I'm dividing, oh, that was really bad. I'm dividing the number line into 3 intervals in this case, based on those 2 numbers those 2 values I came up with. Now we need to test a value in each interval to determine which intervals contain values that satisfy the original equation. So I'm going to go ahead and choose a whole number from each of these intervals. So I'm going to test -1 on this side. I'm going to test 1 in the middle, and I'm going to test 2 on the right. We can't test a number that is right on the line. So I'm going to test them by plugging them back into the original equation. So here I'm going to have 1 over 4 times -1 plus 5 over 8 times -1 is greater than 1/2. So 1 over -4, or -1/4, plus -5/8 is greater than 1/2. -1/4 plus -5/8 will give me, this will be 2/8, so -2 plus -5 is -7/8 is greater than 1/2. That is not true, so the answer will not be in that left interval. Now let's test the middle. 1 over 4 times 1, so 1 over 4, plus 5 over 8 is greater than 1/2. This will give me 7 over 8 is greater than 1/2. That is true, so we know this interval works. If we plug in this one, 1 over 4 times 2 gives me 1 over 8 plus 5 over 8 times 2, so 5 over 16 is greater than 1/2. This would give me 7 over 16 is greater than 1/2, which is not true. So that doesn't work. So our solution is going to be in this interval. It's going to be between 0 and 1 3/4. So we would write our solution as 0 is less than a, which is less than 1 3/4. Now, since we've walked through one all the way here, I'm going to show you guys a little shortcut here. Once you've got your number line broken up into intervals, what we can do is, looking at those 3 intervals, you're going to have 2 options of what your solution can be. It can either be the section in the middle, or it will be the 2 sections outside. So our solution here would have either been the way it was written, or it would have been a is less than 0, or a is greater than 1 3/4. So as long as you trust the math that you're doing, you really only have to test one of these sections and you'll know your answer. So I'm going to go ahead and do this last example showing that little shortcut there. So again, first step we always need to take is find our excluded values. Set anything that's in a denominator with a variable equal to 0. Actually, I'm going to go ahead and do it on the side so I don't have to rewrite the problem later. These will both give me b equals 0, so we know that is our excluded value. Now we want to think of this with an equals sign and solve it. Our common denominator here would be 15b. So if I go ahead and multiply each term by 15b, here my 15's cancel, my 5b cancels, and this becomes 3. 3b cancels, this would become 5. So I got rid of my denominators. Now I've got 5 minus 2 times 3, which is 6, equals b. 5 minus 6 is negative 1. So b equals negative 1. So now I've got my 2 solutions at 0, or my 2 values at 0 and negative 1. So if I go ahead and draw in my number line with those 2 values, split it into the intervals. The numbers that I could use here, I could go negative 2, I could use 1 here. If there's not a whole number that you can use in between, here we can go with 1/2. But again, this time I'm not going to have to test each section. I'm just going to test one of the sections. I'm going to go ahead and go with the section where I can use 1 because that's an easy number to work with. And that will give me 1/3 minus 2/5. And it needs to be less than 1/15. So now this will give me, let's see, common denominator of 15. This will be 5/15 minus 6/15 is less than 1/15. So negative 1/15 is less than 1/15. Since this is true, that means this interval works. Since this one works, that means this one will also, and our middle will not. So our solution here would be b is less than negative 1 and b is greater than 0. That would be our solution. So that's our lesson for today. I know it's a lot of new stuff. The problems have multiple steps, so each problem will take a little bit, but make sure you take your time on this. Make sure you reach out and ask for help if you need it. I'm assuming you guys have maybe been working with each other a little bit to get some help on these last few lessons, because I know they haven't been the easiest lessons, and I've only had a couple people reaching out to me for help. But you guys really need to make sure you understand this, because in a few weeks when we're doing our final, this stuff is going to be on there, and you want to make sure you know what you're doing to get a good grade there on the final. So there's your homework for today. Again, make sure you're getting it turned in on Google Classroom, and yeah, reach out if you guys need anything here.